just gonna review one question from what we did yesterday, and then we're gonna go on to something new. But I think what you guys did yesterday is harder than what we're doing here. So hopefully you'll think the same. And then another thing too, we are going to do up to page 11, and then keep this note packet, because after the quiz next week, we might finish this note packet, okay? All right, so if we go back here, we are first of all going to just review what we did yesterday. So we're gonna multiply these. X minus 5 times x plus 3 equals 4 times a negative 3, which is negative 12. And then remember, we do FOIL. First, outside, inside, last. So the first would be x times x, which is x squared. Outside would be x times 3, which is 3x. Inside would be negative 5 times x. And then we have negative 5 times 3, which is negative 15. And then that negative 12 I bring over in this step. And if it's a negative 12 and I bring it over, it would be a plus 12 equals 0. Now we're going to combine our like terms. So we have 3x minus 5x, which is negative 2x. And then I have negative 15 plus 12, which is negative 3, and that equals 0. Okay? Now, over here, we put x squared here, negative 3 here, negative 3 here, and negative 2 here. And remember what I said yesterday, if you get to a problem and you can't factor it, that if you've exhausted all of this, then go back here, because you probably made a mistake in your foiling or combining like terms. Can you guys think of 2 factors of a negative 3 that add up to negative 2? Yes. Negative 3 times a positive 1 is negative 3. Negative 3 plus 1 is negative 2. So one of these is going to be negative 3x, one is going to be 1x. And then we have to go ahead and figure out what our factors are going to be. So if this is x squared, it's x times x. What times x gives me negative 3x? That's negative 3. X times what gives me 1x? That's 1. And negative 3 times 1 is negative 3. And then this one I put a plus sign in between, okay? So now I can come down here and write down my factors. 1 is x minus 3. 1 is x plus 1. And then what you're going to want to do is do the opposite of each of those. So x is a positive 3 and x is a negative 1. I will tell you when we get to the quiz, which we're taking on Monday, a lot of kids try to do shortcuts and they take these 2 factors, okay? It's not these 2 factors that are your answer, it's the opposite of them, okay? All right, so when I go here, we're gonna learn a little bit more about ratios and proportions, and the reason is, after we take our quiz next week, we're gonna learn about similar figures, and when you do that, you do a lot of ratios and a lot of proportions. So we're gonna review that today. So a ratio would be like, let's say in our classroom right now, we had 14 girls and we had 22 boys. Let's just say that was the case, okay? When you do a ratio, first of all, I shouldn't have really put the G and the B there, but when you do a ratio, Even if they ask you to put it as a decimal, I don't want it as a decimal. I want you to put it as a reduced fraction, okay? What goes into both 14 and 22? 2. 2 goes into 14 7 times, 2 goes into 22 11 times. This would be your final ratio then, okay? I want to show you guys, because I don't know if I've done this yet on a graphing calculator. Graphing calculators can reduce fractions for you if you want to, okay? Did I show you this already? No? Okay. So let's just use this one. Let's say, I just want to make sure I reduced it right. I'm going to check it. So what you can do is go 14 divided by 22. And you can hit enter if you want to. You don't have to though. And then you hit this math key right here. And then you have to hit enter twice. So you go enter, enter, and it will reduce it for you. Okay? Now in that one, you guys easily could have reduced that on your own. But let's say it was something like 286 over 512. And you didn't want to spend the time doing it, okay? You would just, again, you'd go 286 divided by 512, and then you click your math key, and then enter twice, and it will reduce it for you, okay? If it ever reduces it, and it's the same thing, that means that it's reduced already, okay? So that will happen sometimes too. So this was 143 over 2, what was it again, 256, okay? So that would be your answer. But say there was something that is reduced already, like, I don't know, 59 over 111. I think that one's reduced already. Let's try it. So if I went 59 divided by 111, and then I went and hit my math key, and then enter twice, yeah, that one stays the same. So that just means it is reduced already. You don't have to reduce that. Okay? All right. So now we're going to look at this first example. And it says a tight end scored 6 touchdowns in 14 games. Find the ratio of touchdowns per game. Okay? So this tight end did 6 touchdowns in 14 games. Now this is one we can reduce by ourselves. What goes into 6 and 14? 2, right? 2 goes into 6 3 times, 2 goes into that 7 times, and that would be our answer. So when there's small numbers like that, you certainly can do that, but you could use your calculator to check it. And never put them as decimals, even if, like this problem says, find this to the nearest tenth. I want you to always do it as a fraction, okay? So this problem right here says, the total number of students who participate in sports programs at Quarry High School is 470. The total number of students in the school is 835. Find the athlete to student ratio to the nearest tenth. So what we're gonna do is take our number of athletes and put it over the total number of students, which is 835. And now you certainly could sit and like divide it by 5 and see if that works. But let's use our calculator on this one and go 470 divided by 835. And then you go math, enter, enter. And it can be reduced down to 94 over 167. Okay. All right, so that's ratios. Now, another type of problem that you're gonna have in this section is something called extended ratios. Extended ratios are something that have three numbers in order like this, and they're connected by, are these called colons? Yeah, I couldn't think of that for some reason. So say that something they tell us is 2 to 5 to 7, something like that. What happens then is you would think of each of these as one being 2x, one being 5x, and one being 7x. You just put x with each one of them. So if we go down here, they say we have a triangle, okay? And it says the ratio of the measures of the three sides are 4:6:9. So what that means is you're gonna put 4x with 1, 6x with 1, and 9x with 1, okay? The other thing they tell us in this problem is our perimeter is 190. So our perimeter is 190. Anyone know how we could write an equation for that to solve it? What does perimeter mean? Add the sides, right? So do you guys get, I could add 4x plus 6x plus 9x, and that would equal 190. Now, 4 plus 6 is 10, 10 plus 9 is 19x. Then I divide by 19, and x would be 10, okay? But we're not quite done. If we look back at what they're asking, they want us to find the length of the longest side of the triangle. So we can take this 10 and put it back into all three of these if we wanted to. 4 times 10 is 40, 6 times 10 is 60, 9 times 10 is 90, but our longest side is going to be 90. So that would be our answer. Okay. Then, if we go to this page, so I was telling you guys, once we get into similar figures, we use proportions like this a lot. Yesterday we did hard proportions, where we had to factor. These are easier, okay? When you guys learned this probably in middle school, late elementary school, your teacher probably did where you went 3 times 75 equals 5 times x, okay? And then you could go ahead and solve that. 3 times 75 would be 225 equals 5x, and you would divide by 5 then, and x would be 45, okay? And there's absolutely nothing wrong with doing it that way. There is a shorter way, however. When you are given a proportion, and this works anytime that you have just single numbers in 3 of the spots, and then a single variable in the 4th spot. What you can do is punch this right into your calculator and not have to show any work. So what you can do is multiply these two. So go 3 times 75, and then you divide by what's opposite your x. Yep?
Another way to do it is you can just divide 75 by 5 and it gives you 15 and multiply 3 by 15.
You can do that too. They're not always good numbers. You know, like here, 5 to 75 is a whole number that you multiply by, this could be a 7, and you'd get a decimal, but you could still do it that way, okay? I'd like you guys to get used to doing it this way. I'd like you to multiply these and divide by the one that's opposite your x. So basically, you're gonna go to your calculator and go 3 times 75 divided by 5. Did you get 45? You should, okay? On these, you don't have to show work because you can just punch that in, okay? Do you guys get here that you can multiply those two and then divide by 7? So what is that? And this one would work too to use Kyle's way, but what do you guys get for this one? 30, okay? And again, you can just punch in 10 times 21 divided by 7, okay? Now, when you start to have more than just an x, then I would suggest you not do that, okay? So here we have a 4 with our x. Here we have a +1 with our x. Then I would suggest you do it using algebra. So what we're gonna do here is multiply these two. 20 times 6 is 120. And then we're gonna go 5 times 4x, and 5 times 4x is 20x. We're gonna divide by 20, and x is 6. Okay? Same thing here. We're gonna multiply these. Now what I'm gonna do is put the 2 outside, and I'm gonna put the x plus 1 in parentheses, and that's gonna equal 3 times 7, which is 21, okay? These you can get a decimal for. So I was saying if they ask you for a ratio, I don't want a decimal, but when you're solving for algebra like this, don't be surprised if you get a decimal, okay? So we're gonna distribute here. 2 times x is 2x. 2 times 1 is 2, and that equals 21. And then I'm gonna subtract 2, and 2x equals 19. Divide by 2, and x is 19 halves. You really could leave it like that. That's an improper fraction, but you could leave it like that. Most people would just divide 19 divided by 2, and you're gonna get 9.5. The only way you would get it wrong if you left it in a fraction is if it wasn't reduced. Okay, so if it was 20 over 2, you'd have to reduce it. All right, so now let's go here, okay? So in this one, I'm gonna multiply these two. So I'm gonna go 2 times 3x minus 5 equals 4 times a negative 13. So I'm gonna distribute here again. 2 times 3x is 6x. 2 times 5 is 10. And 4 times a negative 13, I believe, is negative 52. And then again, we just solved this using algebra, so I'm gonna add 10. And I get 6x equals negative 42. Divide by 6, and x is negative 7. Okay. Then, when we go to this one here, we're gonna cross multiply again, and we go 4 times 2x plus 3 equals 8 times 5, which is 40. And then we're gonna distribute. 4 times 2x is 8x. 4 times 3 is 12, and that equals 40. Subtract 12, and we get that 8x is 28. divide by 8, and x would be 3.5, I believe. Or if you reduce that fraction, you'd have 7/2. Either of those would be fine. Okay? Now we're gonna skip this one. This is a harder one to factor. So we're gonna skip this problem, so don't worry about that. And then, okay. And then this last one, what we're gonna do is we're gonna multiply these two, and we get 4x squared equals 3 times 108, which is gonna be 324. And now we solve this too, just like algebra. This is 4 times x squared, so I have to get rid of that 4 by dividing. And then we have 324 divided by 4, which is 81. And then we take the square root. And the square root of 81 is 9. Okay. All right. So I'm gonna, go to your weekly snapshot. Okay. And let's see if these numbers are indeed different than what they're saying now. Okay, so if we go back to our worksheet here, which ones they want us to do. 1 through 3 is correct. And then let me check. 1 through 6 and 8, is that correct?
Yeah.
Yep.
1 through 3, 6 through 13 is right.
And that's right, good. And then 4 through 9?
Yeah, that's
That's
right.
right, okay, perfect. Now, the answers for what you guys are working on today is actually in this workbook. And I'll find the exact pages that it's on. But I believe it's these 4 pages. So I'll leave this open up here. And then you guys can check your answers. It's these 4 pages, okay?
Do we do this in my notebook?
Yeah, do it in your notebook. If you would please write 7-1 day 2 worksheet on the top of your notebook page, that would be wonderful. And the ones that you have to show your work on, make sure that you do.